Back to the code. Let's start off by adding all our competitor prices into a list in order of the competitor field. We'll create a list of decimals since currency fields are decimal data types. I'm calling this list competitor prices, which should be straightforward enough for anyone to understand. Next, we add our prices one by one in order, starting at competitor 1. We use the add method to do this, which is an instance method of lists. Our instance is our list variable. I'm adding a comment to the beginning of this code clause to help make it more readable. Next, we do the same thing, but with our competitor name fields. Since these names are pick list values, we used a list of strings. It's very important that we add our competitor names in the exact same order we added their prices in the list above. Again, I'll add a comment to the beginning of this code section to make it more readable. It's good to get in the habit of adding a lot of comments to your code. Generally, this amount of comments is sufficient. At this point, it's important to understand that both these lists have their respective competitor fields added in the exact same order. Remember that lists are an ordered set of records, and we're adding in the respective competitor fields to each list starting from competitor 1 to 2 to 3. So we'll know that if we need the price for competitor 1, we get the first value in our competitor prices list. If we need the name of competitor 1, we also get the first value except from the competitor list. Now it's time to find the position of the lowest price competitor by looping through our competitor prices list. This time, I'm going to write the comment first so I can use that as my North Star for what I'm trying to accomplish. Remember, there are two types of loops: the for each loop, which iterates across all values in a collection, and a for loop, which uses an iterator variable to run a specific number of times. Most of the time, you'll use a for each loop, but this time, a for loop might be better. Here's why. In a for loop, we have access to the I variable, which is the variable that keeps track of what iteration we're on. Since our goal is to find the position of the lowest price competitor, the variable I could be used to track this. Let's start writing out our loop. The for loop takes 3 inputs. First is the starting position, which will start at 1. Next is the run condition, which is a true or false condition that tells us if we should do another iteration. We want to run this loop for every record in our list. Since we're starting our iteration count at 1 and our list has 3 records in it, we'll keep running this loop as long as I is less than or equal to 3. I don't feel totally comfortable hard-coding I to be less than or equal to 3, because if we ever expand it to 4 competitors, I'd have to remember to update 3 to 4. It's better to use dot notation to get the number of records in our list instead. There's a list method called size that'll do this for us. Finally, we set the increment, which as usual is I++. This means add 1 to I after each iteration. Now on to our loop logic. This is where all the magic happens in this trigger. We're going to loop across every price in our competitor price list and find the lowest one. To keep track of what the overall lowest price is, we'll create a lowest price decimal variable. Then for each loop iteration, we can compare that iteration's price to the overall lowest price. If it's lower, we update the lowest price variable. If not, we move on. We created our lowest priced variable and left it as null. We're creating this variable outside of our loop because we want it to represent the overall lowest price found across all iterations. If we created this variable inside the loop instead, its scope would be limited just to 1 iteration. On the next iteration, the variable would be recreated and any value previously stored in it would be lost. One thing you need to notice about this for loop is it's not specifically tied to our competitor price list. The loop doesn't actually know that we're looping across that list. It just knows to start looping at count number 1, loop the same number of times as the size of the competitor price list, and increment its iterator by 1 each time. The iterator variable I, however, is the key to connecting our loop with our competitor price list. I is going to be used not only to track the loop's current iteration, but also the position of the price we're evaluating in our competitor price list. The two will be one and the same, and this type of thing is common when using for loops. We once learned that lists start counting at position 0. Since we want our iterator variable I to also track the position of the price in our list, we need I to start counting at 0 too. So we'll change the starting position to 0 and use only less than instead of less than or equal to the size of our list. If our list has 3 values in it, we need to stop iterating on value 2, again, because counting begins at 0. Now, as we loop across each of our prices, we'll use the lowest price variable to track whatever's the lowest price we've found so far. As we iterate across all our prices, if we find a price lower than the lowest one we found so far, we update the lowest price variable with that value. Don't forget that we created lowest price with a null value. So if it's null, we make sure to update it too. The get method we use on our competitor prices list retrieves the value stored in the inputted position. Take a moment to process what's going on in this if statement before continuing. I notice now in our code that we have a chance to slightly optimize it. On 2 separate occasions, we're using the same dot notation get method on the competitor prices list to get the price of our current iteration. There's nothing technically wrong with this, but it would be a little easier if I saved this value in a variable and reused it, instead of calculating it multiple times. I name this variable current price and update all references. By the time our loop finishes running, it will now properly find us the lowest price. But that's only part of what we want it to do. We also want it to find us the list position of the lowest price value. This isn't too hard. Since we're using the iterator variable I to keep track of the list position, all we need to do is save whatever I is in a separate variable whenever we find the lowest price. We'll create a lowest price position variable for this and update it whenever we also update the lowest price variable. Okay, now we know what list position our lowest price is in. Time to update our opportunities leading competitor field. This part is simple. We set our opportunities leading competitor field to whatever competitor is in the same position as the lowest price position. This time, we use the get method on our competitor list, not our competitor prices list. The 2 lists have values in the exact same order, starting from competitor 1 to competitor 3. So we can be assured we're getting the value in the right position. And that's our entire trigger, folks. Let's attempt to save this to see if there are any issues. Luckily, none are found. I should say, this is quite rare, and it really only happens when you have the luxuries of pre-recording your code. Chances are you're going to forget a semicolon somewhere, even if you're doing your best to copy exactly what I've written. Just because our trigger saves doesn't mean it actually works. Let's log into Salesforce and give it a test run. Here we have an opportunity record. Let's update our competitor fields and decide what the expected output should be. Then we'll save the record and see if our trigger got it right. In this setup, we expect our leading competitor field to point to Google since it has the lowest price point of the 3. I'll save the record, hold my breath, and thank goodness it got it right. Let's mix up our values a bit and try another scenario. This time, Salesforce should be the leading competitor. Once again, I save and our trigger got it right. You can keep repeating this process as many times as you need to help you sleep better at night. I mentioned that the null pointer exception is one of the most common errors of all time. Let's try leaving a few fields null to see if our trigger breaks. Luckily, our trigger still works properly even if some of the competitor prices are empty. Realistically, we'd probably have a validation rule to prevent this from even happening in the first place, but it is nice to know that our trigger is pretty bulletproof. Now that our trigger populates the leading competitor field properly, our executive team can now use this field in reports to quickly and easily find out who our major competitors are. Great job on this trigger.